Topic 16, we are going to focus on the area and perimeter of two-dimensional shapes. So firstly, we are going to focus on some terminology. Firstly, a plane shape is a flat shape, also called a two-dimensional shape. An example would be a page. You have a length and a width, but you don't really have thickness. So that's why it's a two-dimensional shape. If you had thickness or height, it would be a three-dimensional shape. For example, a classroom would be a three-dimensional shape because it has length, width, and height. But we are going to focus in this chapter on the two-dimensional or the plane shapes that only have height and width, no thickness or height, only length, width. Next, we need to know what a closed shape is. It is a shape with sides and vertices. Remember, vertices are like angles that have no gaps. So these are all examples of closed shapes. So there's an inside, a clear inside to the shape, and a clear outside to the shape. So you have the boundary, the inside, and the outside to the shape. Similarly here, you have the clear boundary, the inside, and the outside of the shape. Clear boundary, inside of the shape, outside of the shape. Clear boundaries, inside of the shape, outside of the shape. So this is what we refer to as outside or closed shapes, rather, that have an inside and an outside that's separated by the boundary. So now we have different kinds of closed shapes. The first one we focus on is our simple closed shape. It is a shape with a closed boundary where none of the boundary lines cross each other. A shape that divides the plane, the two-dimensional plane, into exactly two regions. So this is the simple closed shape. It's a circle, a triangle. Whereas on the other hand, a composite shape is a shape that can be divided into two or more basic shapes. So we now combine two or more basic shapes. Composite, you can think of composition or compose. In music, you compose music. So music consists out of notes. So you combine various notes to make something bigger and meaningful, namely a composition. Namely to compose something. Even in language, you have what we refer to a composition, like an essay. You have smaller units like the letters. The letters make up bigger units, namely the words. The words are combined into sentences, the sentences into paragraphs. Many paragraphs together forms the composition. So it's composed out of smaller sections to make one big whole. So composite shape, here we can see we have two triangles combined. A polygon is simply another name for a two-dimensional closed shape made of straight lines. So in this chapter we're also going to look at the areas and perimeters of polygons. So the perimeter first of any polygon is the distance around the outside of the polygon. So to calculate the perimeter of a polygon, you simply add the lengths of all the sides, because this outside sides, you can think of it as using a measuring tape and lie it across this outside, across this outside, this outside, this outside, all around, and then you just straighten the measure tape and measure its length. That would give you the perimeter. The area of a closed shape describes the size of the region enclosed by the boundary of the shape. So this is the boundary, the outside lines. So we are looking at what is in fact happening inside the shape, whereas perimeter is what's happening at the outside boundary, that length. The area is about what's happening inside. The area is expressed in terms of the number of square units covered by the particular region, because we could have squares of the same size filling. You can think like the tiles in a room, filling this and then just adding all of those square units. That will give you the area. So let's look at some formulas, some that you are very familiar with. The area of a rectangle is simply the length multiplied by the width. For perimeter, we have to add up all of the sides, the boundaries. So we have a length and a width, then we are halfway around. So if we add the length and the width and multiply by 2, we would have gone the full way around. So therefore the perimeter is length plus width times 2. Another way of thinking of it is 2 lengths plus 2 widths, because there's 2 lengths and 2 widths. If we think of a square, you have the length times the length, which is the same. Or the length times the width, but length and width is the same, so you can just say length times length, which is length squared. Sometimes we also use side times side, which is side squared. And then the perimeter, we have 1, 2, 3, 4 sides or lengths. That's the same. So it's 4 times the length for the perimeter. Length plus length plus length plus length is just the same as 4 lengths. If you look at the parallelogram, it is simply the base times the height. Now, it's actually easy to know the formula of the parallelogram, since we know we are much more familiar with the area of a triangle, namely half times base times height. So we have the height where it means perpendicular or at 90 degrees with the base. So the base and the perpendicular height we multiply by each other and with a half. So if we know the area of a triangle, it's easy to get the area of a parallelogram, because you can connect through a diagonal the opposite sides of a parallelogram, and then you have 1, 2 triangles. So if you calculate the area of each triangle and add it together, you will get the area of a parallelogram. So half of a breadth times height plus another half of breadth times height will give you 1 times breadth times height. So therefore the area of the parallelogram is simply breadth times height. Now what we also need to consider is it's usually easier dealing with triangles that have acute angles. But now if you have an obtuse angle triangle, in order to get the perpendicular height, you will have to construct an extended line so that you can go perpendicular up to get the height. But now when you do your calculations, you do not include this extension as part of the base. The base is simply this 5.6 centimeter, but whereas the height will be 3 centimeter. In a case like this also, if you are just given the lengths of this side and this side, you can obviously calculate the length of the other side by using this triangle here, since we can use Pythagoras opposite side, or the hypotenuse squared equals the square of the other two shorter sides. The opposite sides of a rhombus are parallel, which make a rhombus is therefore a special type of parallelogram. So you use the same formula for calculating the area of a parallelogram to calculate the area of a rhombus. So the area of a rhombus is also therefore breadth times height, like we had here, breadth times height. Now, the area of a trapezium, we know a trapezium have two parallel sides, of which the one is much longer than the other one. Now, we refer to the one side as length A and the other side length B. So now, in fact, what we do is we take, in a sense, the average of these lengths and multiply it by the perpendicular height, the height at the angle of 90 degrees. So A plus B divide by 2. Remember, divide by 2 is the same as multiply by half times the height. That's the easy way to think for me to remember the formula. I just take the two sides, get an average, therefore take half of it, and then simply multiply by the perpendicular height. So with all this theory and terminology behind our backs, let's focus on a few problems of exercise 16.1. So firstly, we are going to do number 3. Simpiwe is a farmer. She has a square field with sides of 45 meters. She plants 8 maize plants in every square meter. So we can quickly do a rough drawing. So it's 45 meters each side. So in every square meter we have 8 plants. How many maize plants does she plant? So we want to look at what is happening inside, because remember, inside each of the square units we have the 8 plants. So we are focusing what's inside, so we therefore want the area. Okay, so let's firstly calculate the area of this square. We know area is length times length, which is length squared. We can replace length by 45. So we need to square 45. So what is 45 times 45? 45 times 45 is 2025 square meter. Okay, so now in every square meter we fit 8 plants. So we can replace this square meter with 8 plants. So it's in fact 2025 times 8. So 2025 times 8 give us 16,200 plants. Number 4. The fences of a wildlife park forms a trapezium. The two parallel sides of the trapezium are 18 kilometers and 12 kilometers long. The perpendicular distance between them is 9,7 kilometers. This distance here. So what is the area of the wild park in square kilometers? So area of a trapezium, we said we take the shorter parallel side, let's call that A, the longer parallel side, let's call it B, then we have the height. We take the average of the two parallel sides, so it's like A plus B, divide by a half, which is the same as multiplying by the half, multiply by the perpendicular height. So now we can substitute. So what is A? 12 kilometers. What is B? 18 kilometers. What is the height or the perpendicular height, the distance between the two? 9,7 kilometers. So we have 12 plus 18, remember brackets first, so it's half times 10, 20, 30 times 9,7. So half of 30 is 15, so we have to multiply 15 by 9,7. And you will obtain 145,5 or 145.5 square kilometers. Just to illustrate why we know it's square, because remember this is kilometer plus kilometer. So 12 kilometer plus 18 kilometer is 30 kilometer. Here we have 9,7 kilometer. What is kilometer times kilometer? Kilometer square. Area is always square units, whereas perimeter is only normal units like kilometer, meter, centimeter. Area square like square meter, square centimeter, square square kilometer, etc. Number 5. If the area of a rectangle is 200 centimeters squared and its length is 50 centimeters, what is its width? So we know a rectangle, what's the area of a rectangle? It is length times width. We know now the area is 200 square units. Do we know the length? Yes, it's 50. Do we know the width? No, that's what we have to calculate. We can simplify, so 200 equals 50 times W, which is 50 W's. We only want W, so we have to divide both sides by 50. What we do to the one, we do to the other. So W equals Zeros can cancel. 5 going to 24 times. So the width is 4 centimeter. So not too hard. If you know the formula, you simply substitute what you know, solve. You have an equation, solve what you don't know, and you obtain the answer. So finally, let's look at the composite shape. How to calculate the area of a composite shape. So now we see we have a rectangle and a triangle. So we can calculate the areas of the two shapes separately and simply add them up. So let's just see. Let's just study closely. So this whole length is 17. But now from here to here is 5. So the difference from here to here would be the difference between 17 and 5, which is 12 centimeters. So we in fact know the rectangular is 12 centimeters by 3 centimeters. So we can calculate firstly the area of the rectangle, which we know is length times width, which we know is now 12 times 3. So 12 times 3 is 36. We know we always deal with square units if we calculate area. Let's see what we can do with the triangle. Well, it seems that the perpendicular height, or let's rather say the base, we have this base which is 11 centimeter, and then we have the perpendicular height of 5 centimeter. So we know the area of a triangle is half base times height. The base, we said, is 11 centimeter. The height, perpendicular height, 5 centimeters. So we replace. So we have 11 times 5 is 55 times half, or 55 over 2. Centimeter times centimeter is centimeter square. How many times does 2 go into 5? Yes, 2 times remainder 1. 2 goes into 15. 7. 7 times 2 is 14. Remainder 1 over 2. So the area of the triangle is 27.5 centimeters. So now we can get the area of the complete shape. So the area of the composite shape is the area of the rectangle plus the area of the triangle. So it's 36 square centimeter plus 27.5 square centimeter. So 30 plus 20 is 50. 6 plus 7 is 13. 50 plus 13 is 63 plus a half, so it's 63.5 square centimeter for this whole shape's area.